morning. This is going to be for Wednesday, September 4th. It is Solids of Revolution notes. So this is another one kind of similar to the last one, where at first it might be a little bit hard to visualize what exactly is going on. So what I'm going to do is I'm going to attach a couple other YouTube videos that have access to like the geometric software stuff that lets you see these objects actually rotating or revolving around an axis, which is hard for me to show like with my hands or with objects. So what I'm going to do is I'm just going to attach YouTube videos that might be able to help you visualize it a little bit better than I can, just using my hands here. All right, that said, I'm going to go through a couple of the examples for the notes, and then after that, you can always check out those videos, and if you still have questions, please text me or email me during or after class. All right. So we've got a solid of revolution is a three-dimensional figure that is formed by rotating a two-dimensional shape around an axis. And the line around which it is rotated is called the axis of revolution. All right, so basically what that means here is what you want to do is you want to imagine this rectangle right here being spun around the axis. It's like we're spinning it around that way. All right, so see, it's like I've taken this rectangle and I've spun it around almost halfway. And here we've spun it all the way around. So the idea is if I take that rectangle, right, and I spin it all the way around, it actually is going to make a cylinder. All right, and again, this is this kind of idea. If it's hard for you to visualize this, this is what those other YouTube videos that I'm going to attach will be for. All right, so example 1, sketching and describing solids of revolution. All right, so it says sketch the solid produced by rotating the figure around the axis. So then again, this was just a rectangle. Rectangles are going to make cylinders. There's some kind of things you can just understand here. A rectangle, if you rotate it around, will make a cylinder, or a triangle. If you rotate it around, that's going to make a cone. But anyways, if I'm rotating this around, I've got my axis down here. What's going to end up happening is what's similar to the last one. We're going to get a cylinder. Except notice that this time, right, we're rotating it up and down, whereas up here, it was being rotated left to right. All right, this one is up, down, and then this one is left and right. Okay, and again, it's not going to change the actual dimensions, right? Our height or length, or I guess whatever you want to call it, of that cylinder is still 9, and our radius in here, this radius here is still going to be a 4. Right, like the old height of the rectangle becomes the radius of the cylinder once we're rotating it around that axis. Okay, to identify and describe the solid, we could just say we've got a cylinder, radius is 4, and the height is 9. Or you could say the length is 9. The only reason I use height is because when we have like the volume formula for a cylinder, it's pi r squared times the height. So I'll just be consistent and call that the height, even though it's laying on its side. All right, for B here, we've got a triangle. And again, you just want to envision this triangle being spun around. If I'm spinning it around this way, it's going to end up making a cone shape, something like this. And then again, that height, right, so you would say it's a cone. It's got a height of 5. It looks like I kind of drew over it, but it looks like we've got a 2 right here. So that radius of that cone down here, a radius would be 2. So I could say if we want to describe it, we've got a cone with a radius of 2 and a height of 5. And if you just want to write the letters, that's totally fine. You don't have to write out the words. As long as we get the picture, that's what really matters here. All right, sketching a two-dimensional shape and axis. So here's what's going on here. So it says most vases are solids of revolution. Really, the idea is if they're symmetric, right? Like they're smooth and there's the same thing as we go all the way around, it's probably going to be a solid of revolution. So when it says sketch the two-dimensional shape, it's like kind of like we're going backwards. This time we've got the object in 3 dimensions, and we're trying to cut that down and just look at what it would be if we hadn't rotated that two-dimensional shape around the axis. So it's like kind of like going backwards from what we just did. An example might make a little bit more sense. The two-dimensional shape would look something like this. This is why I'm not an artist. Good Lord, that's sad. Let's try that again. All right, maybe a little better. But that's the idea. The idea is if I'm spinning that two-dimensional shape, right, I'm spinning it around the axis, it would make the vase. Like think about just rotating it think about rotating that around the axis. Right, that's going to make our vase. Again, it's hard for me to demonstrate this with my hands. Check out those other YouTube videos if you have more questions about that. Number 4, very similar type of thing. So we've got this silo here, sketch a two-dimensional shape in an axis. So we've got our axis, and the two-dimensional shape is just going to look something like that, right? Because when I'm spinning that guy around my axis, that's going to make like that base rectangle will make the cylinder, and then the little triangle piece up top, right? That's going to make like the cone on top of it. All right, so rotating that all the way around our cylinder is going to give us, rotating it around the axis is going to give us that silo shape. All right, example 3. So this one actually has surface area and volume. So there's going to be some formulas for these. For these examples, I'm going to give you, you're always welcome to, if you forget these, you can look up the formulas for surface area, for volume. These are also formulas that should be on the board when you're taking a test. But on that same note, since the tests are open note, just make sure you have these formulas written down. All right, so first of all, this is very similar to what we did on the first page, right? So this, we'd have our axis here, and then we're going to end up, when we rotate that around the axis, it's going to give us this, this cylinder shape, right? The height being an 8. And then as we saw right here, right, that when we spin that around, that will become the radius, so our radius is 6. Okay, so if I want to describe it, I could say it's a cylinder with a height of 8 and a radius of 6. Okay, now surface area and volume. So for surface area, this is a formula that I do not expect you to have memorized. This should definitely just go ahead and put this one in your notes. So surface area for a cylinder, right, is going to be 2 times pi times the radius times the height plus 2 pi r squared. All right, so again, that's not one that you need to have memorized. That's in more of an obscure formula. We don't see that one a whole lot. Just be aware of it and have it in your notes, so that way you can refer back to it when you need to use it. Okay, so we're going to plug everything in. So it'll be 2 times pi times the radius, which is 6, times the height, which is 8, plus 2 times pi times the radius squared, so times 6 squared. All right, we go ahead, put that into the calculators, see what that gives us. And that is going to come out to be, looks like 527.79. 527.79. And we were talking about area. So that is going to be, it doesn't give us an actual unit, so I would just say units squared. That will be my surface area. All right, and then as far as the volume of a cylinder, we've got, well, what we've got is like no room. I'm kind of out of room. I'm going to do volume over here. Volume. Volume of a cylinder, maybe you remember this one, it is pi times the radius squared times the height. So it's going to be pi times 6 squared times 8. Let's see what that comes out to be. So we got pi times 6 squared times 8. That is 904.78. And that's going to be units cubed, right? Because when we're talking about volume, the units will be cubed. If we're talking about area, the units are going to be squared. All right, one more example of this. So we got another one. We're finding surface area and volume. So think about that semicircle, right? I'm rotating it around upside down. So it's going to be an up to down rotation, right? Based on the axis being flat rather than the axis being up and down this time. And I'm going to do my best to draw this. It's going to give us a sphere. It's going to give us like a ball shape. So it's going to look something like that, right? I'm trying to draw a ball. All right, it's going to look something like that. Okay, and then, right, your radius is going to be 3. Radius is 3. All right, so if you want to find surface area of a sphere, okay, this is another one I don't expect you to have memorized. Surface area for a sphere is 4 times pi times the radius squared. So in that case, it's going to be 4 times pi times 3 squared. All right, so that is going to be, let's figure out that. So we got 36 times pi, and that's going to be 113.1 units squared. All right, and then last one here, we got volume. Volume of a sphere is 4/3 times pi times the radius cubed. So 4/3 times pi times the radius cubed, right? Our radius is 3. And let's punch that into the calculator, see what we get. Oh, and that actually is going to come out to the same number. Very interesting how that works. Oh yeah, I see it. Okay. Yes, that will actually be the same answer for both of these. You will also get 113.1, except only difference is the units will be cubed because now we're talking about volume. All right, there's a few examples of those. That will take care of the notes for today. Again, please let me know if you have any questions. Text me, email me, and I will respond to you as fast as I can. Should be within a couple minutes. All right, good luck. Have fun.